This video is brought to you by Architect Network and our online platform of courses where you can learn from world-class architects working in some of the practices that you can see in these videos. You can learn Grasshopper, Revit, Rhino Inside, Twinmotion, and some of our new courses on AI, and lots more courses that we're delivering over the next year. So please, if you like this video, check out our courses in the link below so we can keep bringing you more content like this.
What's up guys, and welcome back to the Architect Network. Today we're back with another one of our Architect tours here in London, and we're here with AI Build. I'm super excited for this one. I think it's a nice way to continue from FabHub and Mamu Mani. We're now going to explore AI Build and their amazing 3D printing capabilities, both in terms of the software and the hardware that they have. It looks super cool inside, so without any further ado, let's go and check it out. All right guys, welcome to AI Builds. We're here with Michael and Bedin that are going to show us around. It looks like an incredible space. I'm super excited to learn more. Let's jump into it.
Great. So welcome. Thank you for coming to AI Lab. This is our research center for additive. AI Build is a software company. But this is for us a space where we do a lot of experimentation and quality assurance for anything physical before it actually goes into the software. The AI Build was founded back in 2015 by myself and Dagan. We are trained as architects, and we had the privilege to study at the AA, DRL, and then myself for 9 years at Zaha Hadid, doing aviation projects and cultural centers around the world. Dagan as well for a year, and then he continued his work and research at the Bartlett as a course leader, but also research in high computing with the NVIDIA GPU. And around 2015, we came together to build the company. At that time was purely into our fascination for 3D printing, and because we had a very good understanding of geometry and how we can design algorithmically, we found that we can solve some of the issues of fabrication with the power of 3D printing. So in the beginning was really an exploration. So we strategically work with a few clients and friends around the community we knew. So that would be AKT engineers, Zaha Hadid, to really push the boundaries. And was strategically work with them because we could speak the same language. We could really try to push the boundaries so we can do some really great pavilions in the beginning, from product design to larger structures. And around 2017, we started our journey into building our startup. So we were lucky to be selected by Sitcam, which is an incubator here in UK. They choose about 20 companies per year out of 200 applicants to start a journey into building their startup. So in there was critical for us to, as architects, we didn't have a lot of understanding to build a company, so that helped us to, get the first understanding of how to build it, how to do our HR, how to build the right teams around us. Around 2017, we got our first seed investment from Superseed, a great VC in London, with partners had their own companies and exited before. Great cultural fit between us and understanding. And what was really nice during that period is that many hardware manufacturers came to us, like different extruders manufacturers, like the one you see on this robot, and said, you guys, why you can do all of these crazy pavilions? How is that possible and we cannot, while we have very good machinery? And it was mostly on the geometrical aspect. It's how you control it in an efficient way to make it better. So today we are 100% focused in software, and that investment from Superseed at seed stage was pivotal for us to really focus on one direction for our company, which is critical, I would say, for anyone that wants to build a young company, being focused and do one thing but really, really well. And about half a year ago, we closed our Series A with IQ Capital, a major lead investor, deep tech investor in UK. Deep tech meaning that they also invest on hardware, companies that have and sell hardware. And strategic participation by Nikon. And here we are today. We are 42 people with teams from our sales team and engineering team divided of about 5 teams, our AI team, our geometry team, our back-end and front-end team, customer success, and the AM team and the design team that are located here, which is where all the fun happens, all the experimentation before it actually goes into the software. First robot we ever had back from 2015 is a KUKA with a reach of, I think, 2.1 meters and a payload of 15 kilos. There are robots that can have up to a ton payload, so you can actually hang a whole car on it. And they vary in terms of reach and payload. In this area, Berin is working on our creative experiments as part leading our design team to really push the boundaries of 3D printing. So how we can eliminate support altogether, how we can expand as much as possible. And once these are tested and validated, then it becomes part of a solution that can come into our software. So second stage will come into play where Sofia on the back and Nicoletta will go into quality assurance and material characterization on the second robot. And once that's also done, it will go into our product roadmap, where our developers are gonna test it. Once it's deployed, it's gonna come back here again, test it one final time for a physical test, make sure that what we see digitally happens physically, then is ready to be deployed to our clients. Obviously, as I said, we try our best to be really optimized on what is going to happen, but 3D printing is not CNC. It's not a black and white manufacturing process. You are dealing with environmental conditions. It's very different on printing in an enclosure, very different on printing in Dubai than printing in UK, and every material is different. Especially when you go into critical applications or heavy industries such as aerospace and automotive, they need to use highly certified good materials that can withstand crazy temperatures. They have really specific properties, and these materials because they are highly chemical or highly difficult, they are extremely difficult to process. So this is where a good software and a good hardware marriage is really important, but it's a difficult game. You need to know very well how to use it, and this is what's happening for many years in 3D printing and what at AI Build, together with our partners, trying to accelerate and pass.
This is a bit of an example of what you guys are really good at, is printing these kind of complex forms, but without the support necessary, like support material, right?
Exactly. This, till you get to that point, is very difficult. And if you want to industrialize it for repeatability, you need to go through a lot of iterations. Only then you can actually start repeating the same process. So here Borouin has tried to see with a certain settings and a certain extrusion rate how much it can cantilever from the start, what is the right angle so it still has good adhesion to the bed, and then how much it can cantilever as well. And every material will have different properties. Even the layer height needs to be adjusted. So the research, once you have a toolpath like that, needs to happen regardless. Now, what's good is that we've been doing that for almost 7 years. So the know-how and the data we developed is what is most important in 3D printing. And for us, it's part of our culture to share that so we can accelerate. To share it with our clients and partners, because it's obvious to us that if we are able to remove all of that waste, it's much lighter, faster to print, but it requires the time of exploration in the beginning to get it right. So this is an endeavor we started about 3 years ago. Actually, our origins are coming from plastics. But again, in this case, we got a lot of pull from people out of interest of the capabilities we had. The good thing is, but at the same time, metals are very different than plastics. So when you would you could go away with a spiral infill, as we call it, that goes in a spiral way to print it. In metals, if you do that, it's going to concentrate extreme heat on it. So it's not going to work. So strategies in metals are very different than plastics. Now, that's why we see many people specializing only on metals and only on plastic, and that's good, and that's the way it should be. But in big organizations, what we've seen is that there are very different technologies, different material types, and that requires very different skill sets. So we decided to build a platform that is flexible enough that can and engineers can take advantage of it to use for all the technologies within an organization. For that reason, even our architecture is built into a visual programming logic, so you can stack different operators and build an engineering workflow. So that workflow could be a template for metals, very specific. So if we use metals in a very simplified way, I will use a zigzag infill, while on spiral I can go with plastics. On plastics I can apply a lot of continuity, so I can minimize stringing, but on metals I don't need to do that. So it might be that I will optimize in terms of making sure that I leave enough time for the part to cool on certain areas.
I think like something like this, just explain, you know, again, you're printing this with no support. And there's also a difference, you were mentioning that it's not, you know, there's some people, it's just a constant weld versus printing.
On a plastic, you can do that with a robot moving along the normal perpendicular to that surface always. So what's happening is that the layers are interpolating around. Imagine this as a polymesh, right? If it is a clean polymesh, it's going to have these lines in that way. So this is what it does, and then what the robot can do, is to be perpendicular to that line. Now you can do that with the robot itself. Another way is to have an external axis where you keep your extruder vertical, but your external axis, which is the bed, moves around it. So this is useful for accuracy. We've seen it on metals. It's sometimes moving the robot has some tolerance issues, and is not as accurate as moving the bed itself. So there are different ways, and it depends really on what you do. We work on different verticals: aerospace, automotive, marine, energy, oil and gas. So for example, here these are wind turbine
Turbines, wind blades.
blades. Here is a fork for a bike. This is a propeller. We're doing a space antenna for satellites with Airbus. This is a small section of a Formula car jig, in this case in plastic with carbon fibers inside it, about 40%. Yeah, very varied applications. Usually in large scale we've seen a lot of traction into tooling, so replacing traditional tooling like carving wood into plastic. Obviously there is a sustainability aspect that we always need to be aware, so we try to understand how much waste it is to CNC a part and how you can actually recycle or scrap plastic and reuse it. And it's very positive. We've tested that with companies, and we see great savings on it. In this one, this is a good example of controlling 3D printing at its best. In this case, the client has asked us 1 to 1.2 millimeter accuracy everywhere. And as you can imagine, as this is printed, the concave and convex areas, because of gravity, are going to change. So what we had to do is compensate to what it actually is going to happen. So we can negatively push the tool path to what our scan data showed us. So we had to print it one time, see what happens with gravity, scan it, and then compensate to that, and then we had that accuracy. Further, in this case we use make continuous, which is a capability inside our software, so that we eliminate any jumps, and also sorting, which is critical. You need to be aware what is your A surface, basically the surface that wants to be the nicest, and how you sequence it as you print to be in the right order to get the best result. And then other things we've seen over the years as we print it, a typical problem is when you connect two layers. One, the inside layer can push your A surface and have a visible line. That is not acceptable, especially if you do art pieces or you need to have accuracy on your jig. And in this case, we had to, once we identified it in this lab, then we had to go back to the developer and say, okay, how I can control the offset only of these areas, of these two layers, so I don't have that. So this is pretty much how it works. We test many things here, we find the problems, and then we develop them. This is a very good example of showing traditional 3D printing, Cartesian 3D printing versus robotic 3D printing. This is a prosthetic leg, and it's printed layer by layer. As you can see, in large scale 3D printing, layer by layer is going to create this very ugly artifacts here. And if you use non-planar capability, you can actually push the extruder and vary the thickness so you can follow the geometry. In this case, was done also with the Cartesian system, and that depends on the profile of the extruder, of how much you can push it. But in this case was done non-planar, so it's stuck, but the extruder will follow normal to the surface. gives more flexibility to how much you can extend, but in metals especially is critical to make sure that the extruder, the extrusion direction is always normal to the previous layer for better crystallization of the metal.
It's also much more beautiful. You know, it follows the geometry. It's
Yes.
yeah.
We've
accentuates the
seen it
geometry.
also for stress lines. It's gonna support better. There are cases on automotive jigs that non-planar helps the strength because in the Z direction it's very prone to open up. We also work with companies such as Sika in concrete 3D printing. We have some great US and European companies really making some very cool prefab
Do you feel
houses.
this is the next step to building houses or architectural elements with concrete?
I think it's improving. I wouldn't say that like 5 years ago.
Yeah.
But now that the material is getting better and we are able to control the structural properties of the material, I think we will be able to do more.
Yeah.
It's still very liquid.
Right.
I believe the more we start making it more viscous, then we will be able to do more courageous designs,
Yeah.
can deliver more. But these things always go hand in hand with the pricing and the costs of the whole life cycle of that type of manufacturing.
Yeah.
What we do a lot is try to understand it's not just the cost of a machine at the end of the day, but what is important is to analyze the life cycle of the whole process. So from the design all the way to the finished part to really see where the ROI lands. We've seen many times that we focus a lot on the price of the machine, and that can delay innovation. But actually, if we are able to map the whole step and minimize the steps to print a house with concrete 3D printing faster, then it makes sense.
It's exciting.
I think it's getting there for
Yeah.
sure. I just wanted to be a lot more courageous with the concrete 3D printing. It's still 3D
in
printing.
terms of the design.
Design, yeah. I still believe wouldn't make much sense to me to have a straight wall.
Yeah. When you can make wavy walls and things.
Wavy for acoustic reasons, what also purposes that designs that have a purpose. But yeah, be a lot more creative is something we need to push a lot.
So as you can see, it's a bit like dirty, like it's used by one of our clients and they send it here to us to showcase. This is for mining and oil industry. They use these molds to do sand casting. So traditionally you would have a wooden block and you would carve out it with CNC and have a solid full wood pattern to do the sand casting. But in this case, we can control the infill density inside, which means that here, like when you will have some like forces, you would use like solid infill, like 100% infill, and on the other side you might go up to like 50% infills, 30% infills. So this is what we've used here as a strategy, which results in lower weight in the mold, and it will mean that they will use less energy to produce the parts. So yeah, this has been used for 150 production runs. It has been tested and it showed that like we would get around 75% reduction in the time, and then like up to 50% reduction in the energy use.
So they cover it in sands, they take the mold out, and then they pour the metal in, essentially.
Yeah, they use this as a turbo. It has like two parts, one on top and one on bottom, and they put it in the sand and they manufacture parts inside. So in this project we worked with AKT and they were looking for a solution to join like 5 bamboos in one joint, and this is a custom-made joint by them. So it was for a rural area where they had to build them very cheap and fast. So they were looking for solutions. And if you want to make this by metal, it really costs a lot, and it's like custom made. So it takes a lot of time and costs a lot. So we made a prototype for them using polymers, which you can reduce the weight and the cost as well.
Pretty light as well.
Yeah, it's not solid inside, so we can always control the density, as opposed to the metals. When you do a part from metal, it needs to be like solid because you cast the metal in it. And here it's a different kind of node. This again like joins, it's in the junction, but it's joining pipes. Here we use the different slicing method where you kind of slice it in a prism. It's still under development.
It's a really cool pattern. Like, I don't know if you can see that on the camera, but it's almost like it's coming out from the middle.
Yeah, so in this one we can print it as a single piece and with no supports. And you can see all these like cantilevering areas and all these joints. So it's actually a very complex geometry to print as a single piece and with no supports. But everything you see here, they have been built with 0 supports.
Yeah, that's amazing.
So like there is almost no post-processing unless you need to have a smooth surface and you would CNC it. Otherwise, we don't have any post-processing for removing the supports. Again, in this geometry, like you see a lot of cantilevering angles and a lot of voids in between the segments. This is also printed as a single piece. This is a gripper for automotive industry. In the automotive factories, they use a lot of different grippers to pick and place things.
Yeah, to like take the windscreen out and things like that.
Exactly, or like put the window inside the car or pick and place the door parts. So in their whole manufacturing process, they use very different kind of grippers. And this is the gripper with suction cups.
Oh, wow.
So as you can see, all the suction cups are connected to a pipe, and then with suction, they can like go to a surface, take it and put it somewhere. And in this one, this is so traditionally the grippers are done with very big metal assemblies, which the companies usually outsource them, which means that for a big metal gripper, you need to have a very high payload robots, because the robot needs to pick the gripper first and then the part first. So if your gripper is heavy, it means that you use more energy and you use bigger robots. Right. What we try to do here is to optimize the topology of the geometry first, make it a single piece, and then make it without like using metal assemblies, but using other things. Like here we use the wood-based material.
Wow.
Yeah, so this is an example.
Really cool shape. And of course, we can't continue without talking about the elephant in the room with the giant spaceship.
Yeah, so if you've heard about Artemis II mission, it's a collaboration with NASA, ESA, and other companies together. So they're going back to the moon. They just did their launch last year for a successful launch. So for this mission, they were exhibiting in the Goodwood Festival of Speed. Right. So they wanted to showcase their the model of their rocket, but they wanted to show also a different technology. So they also wanted to talk about the technology in manufacturing. So what we did for them is to print this part as a single piece. So it's around like 3 meters. It has built a single piece in under 24 hours.
Wow.
And then it started the conversations with them about printing in non-gravity. So now people started exploring about printing technologies where there is no gravity. But the future would be like if they send the printers to the other planets, they can start building things for habitation using no gravity, but all the materials that they can source from there.
So this is printed with these guys, and it's just simply the arm can reach that high.
Exactly. For instance, here you can see that the robot it's sitting on a 1 meter plinth. It gives you extra 1 meter printing height actually, because the bed is lower than the robot, and you can go up to like 3 meters easily for a single piece. You can also put robots in the rails, which we don't have here, and it allows you to print on the X and Y axis, like as long as you want. Yeah, here we can see different material partners that we work with.
Oh, wow.
Here you can like see the pellets and filaments and the name of the material manufacturers. My colleague Nicoletta, she's working heavily on material characterization, which means that for each and every material, we do tests. We analyze their thermal capacities, structural capacities, and then embed all this information into our software, which means that as a client, if you like to use this material, you will already know how to use it. And this is an example of, it is an Alta material. This is one of the only certified material for aerospace industry because they need to be extremely durable for extreme conditions and like for heat capacities and structural capacities.
So space PLA.
Yeah, exactly. That's very hard to control, and you need high temperatures and a controlled environment. But like we do all kind of tests here, like ranging from these to like silicone-like materials.
Wow. Do you also have bio-based materials? I saw you have like...
We have, for instance, this is UPM. This is wood fiber based. It is recyclable. It is, it is bio-based. We also have a lot of PLAs and PETGs that come from ocean recycled plastics. You can change always the percentage of the recycled material inside it because it affects the structural stability of the materials. If you are going to use it for very heavy structural purposes, maybe you would add more carbon fiber or other reinforcement materials inside. These three they used to be our own R&D extruders because like 6 years ago, the market was not very mature, so we had to build our own research extruders. So we were also putting a lot of effort into hardware and testing how the technology can get better. But in time, like the hardware manufacturers started doing better hardware, so we decided to do partnership with them, and now like they're sending their extruders here. Yeah. Here is a Wasp extruder. Here we have Typhoon, Pulsar, Seed, Weber. So all these hardware manufacturers, their focus is to do hardware. It means that they do their job best and they really develop good hardwares, and they send them to us, and we make the deep integration with the hardware. So we make sure that our software, hardware, and the robots, they can all work together perfectly, and we do the quality assurance here. And we also sometimes give feedback to the manufacturers. For instance, in the nozzles like that, when you have like flat ends, you won't be able to do very flexible prints, where like we develop together more like a longer chamfer angle and like more pointed nozzles.
What's the general difference between, you know, using this head versus that head versus that head? Is it the size of the print or the speed? Like what's the difference between each one?
Mm-hmm. I would say the application. First of all, the scale of your application and the purpose of your application. If you want to do like smaller scale, you can go with entry-level extruders with probably filament extruders and go with like smaller nozzle size. But if you want to do like larger scale industrial applications, you can go with machines that can extrude up to like 40-50 kilograms per hour.
Yeah, you're saying it's also like how long they can print for and how much.
Yeah.
It's epic. I mean, so if you get the size comparison of that.
Yeah, so it's really about like your application, what you want to print, what materials you want to use, and what kind of infrastructure and system you can make in your facility.
They look super cool, this one in particular.
So this is a good presentation of different capabilities our software can do, and what AI Build is quite known for. Most of them are done with a robotic system, so we can have the flexibility of a 6-axis, how we can actually rotate the extruder in a certain angle, so we can access more difficult areas of the geometries. And these are just the representations of different ways of controlling the machine. One is called the segmented one because it's the robot can jump from different areas. And in this case, it has printed that part in this direction and then jump through this direction to complete the other branch. What is critical here to know is that what happens with the robot is that if you don't program it well, it can clash with the part and destroy it. So how you need to program the robot to jump into another area of the print without colliding with the part, and this is what we call the travel lines. And then on top of that, you have the sequencing, which is how you sequence the different parts of the part so that you can print it faster, and that can also be driven by structural purposes, which are related to the thermal properties of the material. Another way to print is non-planar printing. As you can see, the layers start horizontally and then start to become more curvy.
This is the printer here, right? Where you,
yes,
essentially this thing is moving.
Exactly, normal to that curve.
Yeah. Amazing.
This is another good example that we call cupping. So here Berin is trying to cantilever as much as possible. Obviously that part could be printed that way, but the purpose was to see how much we can span. And bear in mind that to get it flat, it's a combination of the material characterization we do. So every material will behave very different, and as well the extruder or the technology you might use. Another thing we do a lot here with our software is control the machine choreographically. So how we control the speed of the robot in conjunction with the speed of the extrusion rate. To give you an example, traditional 3D printing will have a very constant speed and constant extrusion. In this case, as the circle becomes smaller, there is a heat concentration, so the material starts to fall apart. That's an object to show that we can achieve best quality once you have a very good deep integration with the machine. So the software should be highly deeply coupled with the machine, otherwise you will have these issues. Similar thing then can be applied on more complex geometry. So what we do is to analyze the design that comes into our software and see where are the cantilever areas, and then apply different manufacturing instructions on it. So according to the color diagram that we'll have, so red being more cantilever, the robot will do a certain action.
Is this the AI Build mascot? Or is this,
This is what we call the project sphere. Here we have a robot integrated with a lot of sensors like thermal cameras, static cameras, nozzle cameras, vibration sensors, heat sensors. You can see them all integrated around. What we do here is that we generate prints, and sometimes we put defects on purpose, and then we train our models to see like if we can detect the quality. So in this way, like while we're monitoring our print from our software AI sync, it can like alert you and say there is over extrusion or there is under extrusion, which saves time of prototyping and which can also be used for quality assurance. Because otherwise you need to like manually watch your print and see if everything goes right. But then if you have a whole integrated system with the sensors, it means that you can monitor it from a software and like you can do the quality assurance and you can get alerted and save time and material.
so this is essentially your analysis chamber.
Exactly.
I also like that you've got a regular 3D printer. I feel more at home seeing that thing.
Yeah, the other thing that is important about our software is that we are machine agnostic, which means that for every technology, every scale, we are able to integrate the hardware to the system, and you'll be able to control all of the hardware from one platform. Like one platform to rule them all. That's it.
Like the lord of the printers.
Yeah. So that's why you can see all different things around.
Yeah.
Hello everyone, my name is Michael Desilas. I'm Chief Operational Officer and co-founder of AI Build.
Michael, thank you for the amazing tour. It's a super cool space that you have here, loads of futuristic prints and robots. It's a really amazing space that you've created. I know you gave us a little bit of an introduction, but just give us a brief overview. AI Build right now, you're mostly focusing on the software. You were tinkering with the hardware a little bit and you kind of use it a lot, but give us an overview of what AI Build is covering right now.
Sure. So AI Build is a software company at its core. It's operating for 8 years now. Through our journey, we've developed hardware, we did a lot of printing, and as the industry evolved, we've seen a lot of pull from hardware manufacturers. And today we are privileged to have over 20 hardware manufacturers that vary from robotic systems to very large gantry systems and different types of extruders and for different material types, from high performance alloys to high performance polymers. And AI Build partners with these people, and we offer together a system, a large scale 3D printer. Could be a robot on a rail or a very large gantry system or a robotic system to 3D print parts. This could be very large tooling, such as large molds for industries in aerospace, in automotive. We see this technology applied a lot in marine and energy as well. And what AI Build is known very well is the very efficient control of these machines to print efficiently with as much less waste and more flexibility.
You obviously come from an architecture background, you spent a number of years at Zaha. Here it seems you're covering a ton of different industries, automotive, aerospace, and construction. What do you think about the future of 3D printing in terms of the construction industry? It seems like other industries are more prime right now, but as this maybe scales up, we saw that concrete example there. Do you feel 3D printing is going to have a big role in the AEC space?
Yeah, I'm as an architect, I want, this is my love, this is where I'm coming from. So I'm very optimistic about the future of 3D printing in construction. What we've seen through the years is that, and really this was for us the almost the frustration we had with the industry, that we want to design extremely creative projects, but the construction is not picking up as fast as we can design. And that was the primary goal, why we built AI Build in the beginning, to accelerate that through the skills we had together with my co-founder Dagan. We have been exposed through a lot of algorithmic design, and we were able to use our skill set to solve some of the fabrication difficulties we all know architecture has. I'm seeing a lot of development happening in architecture, but I think it should be a teamwork. More companies should work together to accelerate this technology. It's still very regulated. We have to go through many regulations to bring a building into fruition, and there are many aspects and different teams that are involved to make a building a reality. So I think the problem would be that sometimes that we work in isolation as architects. We need to be a lot more involved into the construction stages and try to educate more so that everyone can use the benefits of this technology. And I'm very positive if we work together, is gonna get us there faster. That's pretty much the culture and the ethos we have at AI Build too. We believe that we need to help first to get help back. Lay down everything, as we call it, on a plate so we can show the benefits, do the hard work, and that way we can accelerate it.
Do you feel like there's any particular thing that would help advance it? I mean, there's obviously regulations, like can you even insure a 3D printed building right now? But in terms of the actual, if we put that aside, to actually 3D print a building right now, you see people printing in concrete in one go. Do you think there's different approaches that would help speed it up, like printing parts that you assemble rather than printing in situ? Is it a material development, like, concrete advancements so that we can print? Yeah, do you feel there's any of these things that would really help to push it in the construction industry?
Yeah, I'm inspired by the people that are working, especially in concrete 3D printing, because it's not easy. They are dealing with extreme rates of extrusion and very difficult material properties that are required and driven by specific regulations. I think it's a combination of all of those, but at the same time, companies need to focus. I know from my perspective, we try to do many things in our journey before, and it doesn't work well for a young company that tries to do an innovative thing. Usually, don't take me wrong, there are companies that have achieved great things doing more, but focus is important. So in context, we are seeing more companies coming out and focusing on different things like prefabrication on-site, manufacturing with autonomous robots, and we see also companies that are taking care of the reporting and analytics of that part of the manufacturing process. All of those at the moment are not good enough to accelerate it, but individually are doing great job. I think we need to continue in that and support it more for it. I cannot see the future or know where it's going to go. My gut feeling is that we need more of those companies coming out and trying, because the more we fail, the more we will learn. That's my view on it. Now, I think on-site manufacturing can help a lot. But it depends on the parts. All of these needs to be laid down in a life cycle of manufacturing of the whole building construction complex that it requires. 3D printing is going to help. We should see the 3D printing technology as a tool for us to help us design better. So it gives us that flexibility. What can we remove through the process of the construction? So we know that we need different teams to put together the MEP, the electrical, the walls, the insulations, how we can make all of that system more streamlined with with the help of 3D printing is probably, is where my gut feeling says should go. So imagine that we are building walls that already integrate all of these elements and is part of the design as a system. We all talk, especially in our community, about building and designing systems rather than just form, the skin, the bones. I think this is, together with this emerging technology, I think this is the opportunity for us to take it from the scratch, from the design process, all the way to manufacturing and find a very good manufacturing process or workflow from design to finished product. I think the benefits will speak by themselves then.
Yeah. Obviously, your company is called AI Build, and I know you have a background in computation and all that kind of stuff from Zaha and in the architecture world, and now you're utilizing AI in the software side. Maybe talk to us about like what kind of AI are you using to support your printing process and your software?
Sure. We use AI a little bit, or our approach of using AI is a little bit different than others, I would say. We've been trying to do that for many years now. I'm a little bit sad about the hype of what's happening now, because sometimes we just make things to look cool, but not really using AI to help the users that are using an end product. For us, is driven by the AI. Our AI roadmap is driven by the requirements of our clients. It's driven by the industries we are dealing with. Because we work in highly regulated industries such as construction, aerospace, automotive, we've seen the need to use AI to accelerate some of the processes that are needed during the fabrication of certain parts in these industries. To give you an example, a metal part that can fly or be on a plane needs at least 1 to 2 years to go through, to be approved to get into a plane. And what happens in this case is that they have many processes to certify it that happens manually with CT scanning, and they need to destruct many parts to see what has happened through the process. So one aspect we work on is to do process monitoring, so we can monitor the part, and we implement machine learning algorithms to this is not pure AI, to detect problems as a first stage when at the point that it happened, which is very important for these industries, because then they can document the whole process of their manufacturing and actually get the certification faster. So this is one aspect, and the other aspect is from the perspective of the user, how we can accelerate 3D printing for everyone. For that reason, we integrated OpenAI with our geometrical architecture.
Right.
So rather than using ChatGPT to text and using prompts to get a response, we take the advantage of using natural language, because that way anyone can use a highly engineering software. Also provide it and put it in front of younger generation much easier. And what we do is that prompt, we connect it to specific engineering operators, as we call it, which are code of blocks. So what's happening is that we would type print slice my bunny, and this is going to automatically apply an operator that two operators that loads the design that you have on your data and then slices the design. And then this goes into a further level where you say, okay, now I want it to have an infill density of 10%, and it adds that. It can become even more complex. Can I filter the first 3 layers of that print so I can make my extrusion rate fatter or thicker? So full control.
Just giving the user the ability to just say what they want.
Exactly. This is obviously, we have about 150 operators that they do different operations within a engineering workflow. And the combinations of them makes the print more efficient. What has happened is still people that are starting in 3D printing need to have a very steep curve of learning. And this really blocks them to print more, because at the end of the day they just want to produce a part. This is what they care for. They are very aware of the problems. Everyone is aware without being skilled. You can obviously spot if there is an issue on a part. And usually they would go back to the experts to ask for advice. And this was really the generation and the idea of connecting OpenAI to the operator. So rather than needing to learn really quickly or ask at all times an expert, you might don't have access on it. You in a way have that instructor with you that can drive you through.
I saw you guys also made a text to geometry, like someone typed in, I think it was around Christmas, like Christmas tree, and it designed it. Do you think that's also going to be a big part of the future, where it's like text to design, and then they could come straight to you and print it, or use your software to print it? Do you think that's going to play a big role?
Yes. We see many that focus on the design part. We are not focusing on the design part. We focus on the manufacturing part, and we want to stay focused on that. But it's really good. We see baby steps on it, such as design a cube and fillet the cube, which basically connects, a function in Rhino, such as fillet the edges. It's the same thing. It connects a prompt to an operation within a platform. What I would like to see is more control between the creative aspect, Midjourney, and these people are bringing us, actually generating low poly clean models. I think that approach for me is more creative. I find this interesting, but I also understand that people need to try the other way around. First, we need to also understand how we can generate a geometry with a prompt, but not in reference of something else. Is the same like in what we discussed. In a way, it's an emerging technology. Both need to run in parallel and see where they're going to meet. But yeah, it's very good. It's going to become even more fun when we will start adding environmental conditions into that, and we can input more structural.
You could totally see a workflow where someone is mid-journeying something. Now we know 3D's coming pretty soon, and okay, it's going to be like a pretty horrible mesh at this point. But that's actually where someone like yourselves could come in, and as that mesh gets better, you could slice the model and print it using plastic or metal or concrete or something like that. That could really be a powerful workflow.
Yes. It's like almost, it's also the benefit of, that's the start, but I like a lot the fact of the creativity, improving the creativity, because we've been, I was privileged to be around very good modelers and very good coders that can do things extremely fast. So for me, there's no point of using AI that is going to give me not the perfect solution I want. In the same time, I can model it. So we need to be a little bit critical about that. It's the same like, should I code it or should I model it? If it gives me 30 iterations, then modeling it then makes sense. Same with AI. So I think these are the questions we need to make sure we are answering as we are developing these tools. So it really benefits us at the end.
Yeah, I mean, we've mentioned you've come from an architecture background and now you're in this manufacturing software side. Talk about that transition, like what were you doing when you were an architect in Zaha and how do you feel now? And also you still hire quite a lot of people with architecture backgrounds, so they're computational specialists or they've, experimenting with robotics at uni or in practice. How have you transitioned from that architectural role to what you're doing now?
Yeah, it's interesting. Everything for me changed once I did my master's at the Architectural Association, DRL, because there was a shift of thinking of how we think architecture through designing systems. So everything we design should have a purpose. So this really stuck with me. Plus, the creative outcome of it is really appealing to me. I really like nature and how we can understand and program nature in our benefit, how we can learn from these, like the cellular automata systems, the reaction diffusions, and the L systems are things we would study and would make sense because then we can apply them into the flows of people to structural systems of a building, to facade strategies. So it just made sense from my diploma that would be very static. And obviously I had to learn the basics, but really DRL made a difference for me. And then I've seen this was really enhanced at Zaha, where I was between some exceptional people that they would be very skillful, and you could see all of these have also different interests. They are innovators as well, people that would think that way. Designing systems would also be engaged with other things, such as fabrication. They would try to make things themselves. They are makers, innovators. So that was just an enhancement of that journey for me. And then one thing led to the other. I'm not really thinking of my future too much. It just went to be that I joined with Dagan. Dagan was someone I was respecting from university a lot, had a mutual respect between us, and we could see that our skill set could complement each other. And we wanted to design systems and make the systems. So what happens, this is really the ethos we had back then and what we are doing here at AI Build. It might look different because there are different industries, different applications, but the problems are similar.
Yeah, the
On the approach, very, very similar. I miss pure design. I like systems, but I'm also formalist. I like an elegant shape.
But you can see in your software, it's like very the graphically beautiful, the interface is beautiful, which is super nice.
Thank you, thank you. Similar things, we realized that as you plan an airport and you need to learn about signage and how you make sure a person would move from location A to location B as fast as possible. In this case, an airport that is a processor. What is the case? What is the user story? What is the experience of a user in an airport is very different than a cultural center. So I had the privilege to be exposed on that at Zaha from different projects. And I've seen very much same similarities in UI UX, designing a product. Don't take me wrong, people that have trained and been educated doing UI UX know their job much better than me, and they do much better job than me, but still the logic of thinking it, the way of approaching the problem is very similar. Now we have a great designer in UI UX that is coming from that background. It's incredible to see how he thinks compared to an architect. So that's also a learning that I'm going through now. I'm learning a lot. That when I thought that I could solve things geometrically, algorithmically, a software engineer, an engineer that has actually studied it, is very different. Is much better than an architect that learned to do C# and Python, because it comes when you want to productize it. There are many other aspects that play. Now, we still see that we have, now we understand and we are learning that we need to have that distinction. We need to have the right skilled people into the right parts of the teams. But we believe strongly that we need the help of architects as well. Because they are multidisciplinary. They, by default, they are able to think in many dimensions. It's almost natural to them because we've been exposed, leading, for example, a construction project entails many, many things, from the design all the way to the manufacturing, right? Every little bit just by default makes them be multidisciplinary. And that helps have better conversations together with the actual engineers, the software engineers, where when it comes to problem solving, architects are extremely creative to find ways around a problem. So we find it critical, and we still celebrate and bring more architects here. And at the moment, the combination for us works well.
We've been asking this to a lot of the people that we've been doing tours for young architects in the audience that either have ambitions to come work one day at AI Build or simply get into robotics or 3D printing. What advice would you give to get into that space, and what kind of things do you look for when you guys hire architects?
We do that with something we do with all our employees before we go together, is to invite them to the lab here so they can actually experience it. it is a very niche industry what we are working on. So it also we are a young company, so this can have great benefits, but also big risk coming into that. But what we are looking in terms of skills is someone that is very proficient with coding and understanding geometry is critical for us. Other than that, other than that, for us is if also it's not only what we require, but also how they would see their career grow within our company. This is critical for us. We have about 99% retention till now because we have a very good culture. At least this is what people are telling me. That is built by making sure that the people that are going to join our company have a future and they have the passion to grow and proactively work on other things. We provide that and grow to what they want to focus on. They can try many things here. Obviously, we work with highly regulated companies, so there is a lot of work to be done. But it's a teamwork that is going to develop and get nurtured over the years. So me and Dagan, at the leadership level, we nurture that a lot because we want to make sure that the people that are going to join our company are going to be the leaders of our company in the future, and they're going to continue enhancing our culture as much as we are going to set up from a founder's perspective a certain culture. We recognize that it can only continue by the people. Yeah. So our as long as we make sure our people are healthy and we work in a smart way, then we can serve better our clients. This is pretty much the most important aspect. Skills and tools can be learned.
Yeah. What about for a young architect really interested in getting into 3D printing? Would you advise buy one of those DIY printers and put it together and experiment, or how would you advise young architects to get into 3D printing and experiment with it?
Yes, I mean absolutely that's the one. Get a very cheap 3D printer so it breaks all the time, so you can learn. And by the time you're gonna gather a bit more money to get something better, you will know how you will take care of it. And during that process, fail as much as possible. Because you're going to learn. For us, fail is good. It's interesting, actually. In every, it's interesting how fail is perceived from different cultures. Yeah. In US, for example, failing in a startup scenario is really good because it means you came out with some very good lessons to continue, while in other cultures would be frowned upon, I would say. So don't be afraid of that. Yeah, young guy, you guys are still very young to try.
Yeah. And the other question we've asked a lot of people is, with 2024, there's a lot going on in the AEC industry of AI, game engines, Unreal, or all these kind of things are going on. Is there anything you're particularly excited about, either within your realm or even outside of it, that excites you at the moment?
I think it's great they are covering the design aspects and the game engines, and so this is we see a lot of work happening there. I think from us, what excites me and almost feels our responsibility as AI Build is to to accelerate on the manufacturing aspect. So how can we learn from these tools that are really fast now, where there is a shift, technological shift, how we can do the same physically? Would be interesting. So that's what keeps me up at night, physical things, so how I can make these things a reality.
Perfect. Well, thank you so much for your time, and thank you for showing us around. It's incredible space, and I'm really excited to see what you guys do in the future.
Thank you, pleasure. Thank you very much.
Thanks for joining us on our tour once again, and a big thank you to Michael and the AI Build team for showing us around. Incredible space, incredible work. I really think there's going to be some really interesting stuff that's going to come out of AI Build over the next few years. As always, if you like this video, give us a like and a subscribe, share it with friends and colleagues so we can help share this knowledge, and we'll hopefully see you in the next tour.